In the questions of local maxima or local minima, I have found that most of students proceed in this way, that they put dx equal 0, and from this equation they get the value of x as x1, x2, x3 and so on, and then to check which of these values of x gives the point of local maxima, which one gives the point of local minima, and which one gives the point of inflection, they use single derivative test or double derivative test for all the points. But while solving this question, I will show that even if information about any one of these points is known to you, that is the point of local maxima or local minima, you can get the information about all the points directly, that which one is a point of local maxima, which one is a point of local minima, and which one is a point of inflection. How I will do? In the solution you will understand. In this question it is given that let x1 less than x2 less than x3 less than xn and further also be all the points of local maximum of f, and y1 less than y2 less than y3 and so on less than yn, and further also be all the points of local minimum of f, then which of the following options is oblique are correct? This is very obvious that if you are dealing with the function y equal to gx, then to deal with the function y equal to g lambda x is also very easy. The only difference will be, if previously local maxima was there at x equal to x1, now the local maxima will be there when x is x1 upon lambda. Everything else will remain same. Many times this trick reduces our calculation, and in those questions we use this trick. And one more point to be noted is, suppose you are dealing with the function y equal to hx, then for the function y equal to lambda hx, where lambda is some positive constant, wherever this function has local maxima, at the same point it will also have local maxima at that point. Wherever it has local minima, at the same point it will also have local minima. And if lambda is negative, the nature will change. Wherever it has local maxima, it will have local minima, and wherever it has local minima, it will have local maxima at that point. And these two things I'm going to use in this question. We use this concept wherever it makes our calculation easy. It is obvious that had it be only x instead of yx, the question would have become easier for me to deal. Therefore, I'm changing the question slightly. That will make our calculation, hence solution, simple. I suppose pi x equal to t, and make the function gt is equal to sin t upon t by pi whole square, that is equal to pi square sin t upon t square. If this has local maxima at x1, then this will have local maxima when t is pi x1, and multiplying by a positive constant doesn't make any difference. And because pi square is a positive constant, dealing with the points of local maxima, local minima for this function and for this function will be similar. Multiplying all these by pi, I name pi x1 by alpha 1, pi x2 by alpha 2, pi x3 by alpha 3, and so on. Similarly, here also I multiply all of them by pi, and now I name pi y1 by beta 1, pi y2 by beta 2, pi y3 by beta 3, and so on. And to check this thing means pi x1 less than pi y1, that is I have to check alpha 1 less than beta 1. To check this thing means multiply the whole equation by pi, I get mod of alpha n minus beta n greater than pi. To check this thing means multiply by pi, I'll get alpha n belongs to 2n pi to 2n plus 1 by 2 into pi, and multiply the whole by pi. This will give you alpha n plus 1 minus alpha n greater than 2 pi. And for simplicity, I will deal with only this function because multiplying by pi square doesn't make any difference. I name it as ht equal to sin t upon t square. H dash t will become t to the power 4 t square cos t minus 2t sin t, that is equal to 2t cos t into t by 2 minus tan t upon, that is equal to 2 cos t upon t cube into t by 2 minus tan t. And as usual, we put it equal to 0. And this equal to 0 means either this is 0 or this is 0. But cos t cannot be 0, because if cos t is 0, then the value of sin t will be 1 or minus 1. Hence the whole will be surely non-zero if cos t is 0. Therefore, this equal to 0 means tan t minus t by 2 is 0. That is tan t equal to t by 2. And to solve this equation, as all of you know, that we draw the graph of tan t and t by 2 and then check about the points of intersection. Tan t, we know the graph of tan t is pi by 2 minus pi by 2, but x is positive given to us, that is t is also positive, hence we are not concerned with the graph on left side. This is a part of the graph in 0 to pi by 2, and then next will be 3 pi by 2 pi 5 pi by 2, it is 2 pi, and so on. And the graph of y equal to t by 2 will be surely of this type. That is, I mean to say, this graph will not be of this type. That is, between 0 and pi by 2, there will not be any point of intersection. How can I say that this graph is not possible? Because it's clear that at 0, slope of tangent to this graph at x equals 0 is 1. I mean to say this is a tangent to this graph. This surely has the slope 1 because derivative of tan t is secant square t, and at t equals 0 derivative is 1. That is the line having slope 1 by 2, that will be surely below this line, and this is the line for which slope is more than 1. But we are dealing with the line having slope 1 by 2. Therefore, I can say this is a graph. The very first point of intersection is this. Second point of intersection of graph is this, and so on. And now I have to check at this point this function has local maxima or local minima. Suppose this point has x coordinate lambda. When the value of t is slightly less than lambda, because this is the upper graph, this is the lower graph, hence I can say for the values of x slightly less than lambda, the value of t by 2 will be more than the value of tan t. Therefore, this will be positive. T cube is already positive, but because this point has x coordinate between pi and 3 pi by 2, therefore cos t will be negative for this value of x. Hence, I can say for the values of t slightly less than lambda, negative into positive means negative. Hence, before lambda, h dash t is negative. Similarly, after lambda, this graph will be lower and the graph of tan t will be higher. It means for the values of x slightly more than lambda, this will be smaller than this. That is, the whole will be negative. But for x slightly more than lambda, this still will be negative. Hence, I can say the whole will be positive for the values of x slightly more than lambda. Therefore, I can say at lambda, the function will have local minima. As my question had become alpha 1 less than alpha 2 less than alpha 3 and so on, and beta 1 less than beta 2 less than beta 3 and so on, and this is the first turning point and it has local minima at this point. Therefore, I can say this point has x coordinate beta 1. From here, I can say beta 1 is the first point where the function has local minima. And second point to be noted is it's not required to check each and every point that whether that is a point of local maxima or local minima, because it is also a theorem that for all continuous function, maxima and minima always occur alternately. If at this point local minima has come, then it is sure that at this point local maxima will come. Therefore, I can say the x coordinate of this point will be surely alpha 1, because according to this information, these are the points of local maxima. Hence, alpha less than beta 1 becomes wrong choice. Note that the given function is continuous function, and because this is continuous, the points of local minima and local maxima will surely occur alternately. That is, if I extend this graph, that is, it is 7 pi by 2, the x coordinate of this point will be surely beta 2, and at the next point of intersection there will be local maxima again. that point will have x coordinate alpha 2. And now we have to check this thing. Mod of alpha n minus beta n is greater than pi for every value of n. Let us check for n equal to 1. It is clear that this length is pi. Clearly this length is more than this length. Therefore, this has x coordinate alpha 1. This I have proved that this point has x coordinate beta 1. And because this is more than this, that is, I can say alpha 1 minus beta 1 is greater than pi. In the similar way, alpha 2 minus beta 2 is more than pi, and this means alpha 1 minus beta 1 mod is also more than pi, because alpha 1 minus beta 1 is positive number. Hence, I can say B choice is correct. And next point to be checked is alpha n belongs to 2n pi to 2n plus 1 by 2 pi. That is 2n pi plus pi by 2. Let us first check for n equal to 1. Alpha 1 belongs to 2 pi to 2 pi plus pi by 2. This is a point having x coordinate 2 pi. This is a point having x coordinate 2 pi plus pi by 2. Therefore, alpha 1 lies between 2 pi and 2 pi plus pi by 2 is correct. It is 3 pi. Obviously, the next point of local maxima will be between 4 pi and 4 pi plus pi by 2, and this point will have x coordinate alpha 2. And obviously, after this point of local maxima, the next point of local maxima will be somewhere here, and that point will have x coordinate between 4 pi and 4 pi plus pi by 2. That is, I can say this is also true. And now we have to check about this. And for n equal to 1, it becomes alpha 2 minus alpha 1 greater than 2 pi. As I told you that the next point of local maxima will be for this value of x, and the x coordinate of this point is alpha 2. Alpha 1 is slightly less than 5 pi by 2. Alpha 2 is slightly less than 4 pi plus pi by 2. That is, alpha 1 is slightly less than 2 pi plus pi by 2. Alpha 2 is slightly less than 4 pi plus pi by 2. It is also clear that this length will be more than this length. Hence, I can say alpha 2 minus alpha 1 will be more than 2 pi. Hence, I can say D is also correct, and C was already checked as correct choice.